There's a study that should change how you think about every aerobic training session you do or skip in your 30s, 40s, and 50s. Not because it tells you exercise is good for you. You already knew that. But because it gives you a level of mechanistic and longitudinal precision about the relationship between the fitness you build right now and the cognitive function and brain structure you will have in your 70s that no previous research had achieved. The study is a 9-year follow-up of the Generation 100 trial, one of the longest and most rigorous exercise interventions in the history of brain health research. Published in Sports Medicine in 2026, led by Reitlow and Hoberg at the Norwegian University of Science and Technology, it tracked 106 older adults from their early 70s through nearly a decade of brain MRI scans, cognitive assessments, and exercise monitoring. And its central finding carries an implication that is both scientifically significant and personally urgent. The participants who entered the study with the highest VO2 max, the highest cardiorespiratory fitness, had measurably larger cortical brain volume and performed significantly better on pattern separation cognitive tasks nearly a decade later. The fitter people were when the study began, in their early 70s, the more structurally preserved their brains looked years later, and the better they performed on the memory tasks that most closely reflect hippocampal function, the ability to distinguish between similar experiences, to form new memories with precision, to maintain the cognitive granularity that aging progressively erodes. Cardiorespiratory fitness at the start of older age predicted brain structural integrity and cognitive performance at the end of older age, across a gap of nearly a decade. But the findings that most directly affect you, if you are in your 30s, 40s, or 50s reading this, are not the findings about what VO2 max did in people who were already in their 70s. They are what those findings imply about what the fitness you build, or fail to build, in the decades before 70 is doing to the brain you will bring to that starting line. Your VO2 max at 70 is not determined at 70. It is the result of the cumulative training history, the accumulated physiological investment, the compound return on the cardiovascular and metabolic decisions made across the preceding 3 to 4 decades. The brain that the Generation 100 study found to be more preserved in high-fit 70-year-olds was not preserved by something that happened at 70. It was preserved by decades of maintained cardiovascular fitness, whose neuroprotective effects accumulated over years before the study's measurement window opened. The brain you will have at 70 is being built right now, in the training sessions you do or skip, in the fitness you accumulate or allow to erode, in the cardiovascular capacity you build or defer to a later year that will be less receptive to the investment than the current one. This is not a metaphor. It is a mechanistic claim grounded in 4 distinct and convergent physiological pathways, each of which has been independently characterized in the research literature, and each of which operates continuously over decades to either protect or fail to protect the aging brain. Let me take you through all 4, because understanding the mechanism is not an intellectual luxury. It is the thing that makes the fitness investment feel like what it actually is, the most important preventive intervention available for the cognitive quality of the second half of your life. The first pathway is BDNF, brain-derived neurotrophic factor. BDNF is a protein in the neurotrophin family, molecules that regulate the growth, maintenance, survival, and synaptic plasticity of neurons. In the brain, BDNF binds to the TRKB receptor and activates downstream signaling cascades that drive neuroplasticity, the strengthening and refinement of synaptic connections, and neurogenesis, the creation of new neurons, which in the adult brain occurs most actively in the dentate gyrus of the hippocampus. The hippocampus is the brain structure most critical for episodic memory, the memory of specific events, places, and experiences, and for spatial navigation. It is the structure most vulnerable to the earliest stages of Alzheimer's disease pathology. It is the structure whose volume was being predicted by VO2 max in the Generation 100 study. And it is the structure most directly and most potently responsive to BDNF. Aerobic exercise produces acute and chronic elevations in BDNF. The acute elevation, the spike in circulating BDNF that follows a single aerobic exercise session, has been measured in dozens of studies and is robust and consistent. The chronic effect, the baseline elevation in BDNF that develops in response to regular aerobic training over weeks and months, is the mechanism through which sustained exercise produces the structural brain changes that MRI studies have been documenting for 2 decades. Kirk Erickson's 2011 PNAS study, which remains one of the most cited papers in exercise neuroscience, randomized 120 older adults to either a year of aerobic walking or a year of stretching and flexibility exercises. The aerobic group showed a 2% increase in anterior hippocampal volume over the 12-month intervention, effectively reversing 1 to 2 years of the age-related hippocampal atrophy that normally proceeds at approximately 0.5% per year in older adults. The stretching group showed the typical age-related volume loss. The mechanism, BDNF-mediated neurogenesis and synaptic plasticity in the hippocampal dentate gyrus, driven by the regular aerobic stimulus. The brain grew, structurally, measurably, in response to exercise. The BDNF pathway operates across the entire adult lifespan, but the research on its age-specific effects is clear. The response is present and meaningful at every age. Adults in their 60s and 70s show BDNF elevations in response to aerobic training comparable in direction, if modestly smaller in magnitude, to those seen in younger adults. The hippocampal responsiveness to BDNF-mediated neuroplasticity does not shut off with age. It continues to operate, and the exercise stimulus continues to activate it, as long as adequate cardiovascular fitness is maintained to generate the aerobic training response. The second pathway is cerebrovascular function, the health, elasticity, and functional capacity of the blood vessels supplying the brain. The brain is the most metabolically demanding organ in the body, consuming approximately 20% of the body's total energy output, despite representing only 2% of its weight. This extraordinary metabolic demand requires an extraordinary blood supply, a dense vascular network that delivers oxygen and glucose to every neuron, every astrocyte, every glial cell at every moment. The maintenance of this vascular network, and specifically the maintenance of its capacity to regulate cerebral blood flow precisely in response to moment-to-moment changes in local metabolic demand, a capacity called neurovascular coupling, is one of the most critical determinants of brain function and brain health across aging. Aging degrades cerebrovascular function through multiple mechanisms. The progressive stiffening of arterial walls that reduces their ability to buffer the pressure waves of each heartbeat, the accumulation of atherosclerotic changes in cerebral vessels, the decline in endothelial nitric oxide signaling that regulates vasodilation, and the development of cerebral small vessel disease that produces white matter lesions visible on brain MRI and associated with cognitive decline and dementia risk. Cardiorespiratory fitness protects against every one of these mechanisms. Regular aerobic exercise maintains arterial elasticity, the capacity of vessel walls to expand and recoil that declines with age in sedentary individuals and is substantially preserved in those with maintained fitness. It promotes endothelial function and nitric oxide production, maintaining the vasodilatory capacity of cerebral vessels. It drives cerebral angiogenesis, the formation of new capillaries in brain tissue, increasing the density of the vascular network available for oxygen and nutrient delivery. And it reduces the cerebrovascular risk factors, hypertension, insulin resistance, chronic inflammation, whose accumulation drives the pathological changes of cerebral small vessel disease. A 2025 BioRxiv preprint from researchers at the University of Lausanne measured the relationship between VO2 peak and cerebral oxygen availability using advanced quantitative MRI techniques in healthy adults over 50. They found that higher cardiorespiratory fitness was associated with greater oxygen availability across the whole brain, in gray matter specifically, and in frontal, temporal, and occipital lobes, and that this oxygen availability advantage was mediated by differences in cerebral blood flow between high and low-fit individuals. Higher fitness meant more oxygen getting to the brain, through better blood flow, through better vascular function. The Lancet published a major review in March 2025, specifically on the neuroprotective mechanisms of exercise and cardiorespiratory fitness, identifying cerebrovascular maintenance as one of the primary pathways through which fitness protects against cognitive decline and dementia across aging. The cerebrovascular pathway operates on a timeline of decades. The arterial stiffness that compromises cerebral blood flow in the 60s and 70s begins developing in the 30s and 40s in sedentary individuals. The white matter lesions that predict cognitive decline in later decades begin accumulating from midlife. The investment in cardiovascular fitness that protects against these processes is most efficient and most impactful when made before the pathological processes are well established, which means the 30s and 40s, not the 60s and 70s where remediation is possible, but starting from a more compromised baseline. The third pathway is neuroinflammation. Chronic low-grade neuroinflammation, the persistent, smoldering activation of the brain's immune cells, the microglia, at levels insufficient to produce acute illness, but sufficient to chronically impair neuronal function and promote the accumulation of neurotoxic debris, is increasingly recognized as a central mechanism in the pathogenesis of Alzheimer's disease and other neurodegenerative conditions. The concept of inflammaging, the age-related increase in chronic inflammatory tone first described by Claudio Franceschi, applies to the brain as much as to the periphery. The microglial cells that are the brain's primary immune effectors shift with aging toward a more pro-inflammatory activation state, generating neuroinflammatory signals that impair synaptic function, reduce BDNF production, compromise the blood-brain barrier, and create conditions conducive to the accumulation and aggregation of amyloid beta and tau, the proteins whose pathological accumulation defines Alzheimer's disease. Regular aerobic exercise is one of the most potent anti-inflammatory interventions available. It reduces systemic inflammatory markers, IL-6, TNF-alpha, C-reactive protein, that are the peripheral correlates of the inflammatory state that drives neuroinflammation. It promotes the production of anti-inflammatory myokines from skeletal muscle, including irisin, which has been shown to cross the blood-brain barrier and directly modulate microglial activation states. It reduces the oxidative stress that drives microglial pro-inflammatory activation in the aging brain. The fitness-inflammation neurodegeneration pathway is the one that most directly connects the sedentary lifestyle choices of midlife to the specific pathological processes that produce Alzheimer's disease decades later. The inflammatory environment of the aging brain is not determined at 70. It reflects the cumulative inflammatory burden of decades of lifestyle choices, physical activity or inactivity, dietary quality, sleep, stress management, whose effects on systemic and neural inflammation have been accumulating since midlife. The fourth pathway is structural, hippocampal volume maintenance, and the prevention of the progressive atrophy that characterizes normal aging and accelerates dramatically in the early stages of Alzheimer's disease. Hippocampal volume loss in healthy aging proceeds at approximately 0.5% per year. In individuals with mild cognitive impairment, that rate accelerates to approximately 3.5% per year. In Alzheimer's disease, the rate accelerates further. The cumulative hippocampal volume that you bring to the beginning of cognitive vulnerability, the reserve of hippocampal tissue available to absorb the attrition of aging and pathology before functional thresholds are crossed, is determined by the history of factors that have maintained or accelerated hippocampal health across the preceding decades. Cardiorespiratory fitness is the single lifestyle variable with the strongest and most consistent evidence for protecting hippocampal volume. The BDNF-mediated neurogenesis pathway drives the maintenance of new neurons in the hippocampal dentate gyrus. The cerebrovascular pathway ensures adequate blood flow to hippocampal tissue. The anti-inflammatory pathway reduces the microglial activation that directly impairs hippocampal neurogenesis. All four pathways converge on the hippocampus and collectively determine how much of it you have left when the pathological processes of aging begin to accelerate. Now let me bring the clinical evidence for the population-level effect of all of this together, because the mechanistic argument becomes most practically compelling when it is grounded in numbers. High-fit individuals show 36 to 88% lower risk of cognitive decline compared to their unfit peers across multiple large cohort studies. The range of 36 to 88% reflects genuine variation across study populations, follow-up periods, and cognitive outcome measures, but the direction is consistent across every study that has examined it. More fitness, less dementia. The relationship is dose-dependent and appears to have no ceiling. Each one, MET increase in cardiorespiratory fitness translates to approximately a 16% reduction in dementia incidence across the studies that have examined this dose-response relationship. The relationship continues at the highest fitness levels measured. There is no point on the fitness curve at which getting fitter stops producing additional dementia protection. The magnitude of the effect, what researchers describe as the attributable reduction in dementia risk from improving from the lowest to the highest fitness quintile, corresponds in some analyses to a 5 to 9.5 year delay in dementia onset. 5 to 9.5 years. The most aggressively funded pharmaceutical trials in the history of Alzheimer's disease research have not produced anything approaching this effect size. The immunotherapy trials, aducanumab, lecanemab, donanemab, have produced modest slowing of cognitive decline in specific biomarker-selected populations with early Alzheimer's pathology at costs measured in tens of thousands of dollars per year. The most powerful intervention for dementia prevention available is free, available now, and requires no prescription, no biological qualification, and no genetic marker. The EXERT trial, published in Alzheimer's and Dementia in 2025, the largest randomized controlled trial of exercise in adults with mild cognitive impairment ever conducted, enrolled 296 sedentary older adults with amnestic mild cognitive impairment and randomized them to either moderate to high-intensity aerobic training or low-intensity stretching and balance exercise 3 to 4 times per week for 12 months. Both groups maintained stable cognitive function across the 12-month intervention, remarkable because mild cognitive impairment patients typically show progressive decline over this time frame. Compared to an ADNI cohort of MCI patients who did not exercise, both exercise groups showed significantly better cognitive outcomes. Exercise, even in people who already have the earliest clinical signs of cognitive decline, slows the trajectory. The implication is both sobering and actionable. Sobering because the EXERT finding, that exercise can slow progression even from MCI, should not be the level at which most people begin their investment in exercise for brain health. MCI is already a clinical diagnosis. The neuroprotective dividend of fitness investment is largest when it is made decades before any cognitive symptoms appear, when the brain has the structural reserve to absorb the full benefit of the vascular, BDNF-mediated, and anti-inflammatory protection that fitness provides. Actionable because the fitness investment is available right now, at whatever age you are reading this. The biology does not close the window in the 40s or 50s. The Generation 100 study found that baseline VO2 max in the early 70s still predicted brain structure 9 years later. The investment returns at every age. It is simply largest when made earliest, and it compounds across the years between when you make it and when you need it. The minimum effective dose for brain health, the training volume that produces meaningful neuroprotective adaptations in the research, is consistent across multiple studies. 120 to 150 minutes per week of moderate to vigorous aerobic activity, equivalent to approximately 3 40-minute sessions at an intensity that elevates your heart rate and breathing to a level where conversation is possible, but requires effort. This is not an elite training prescription. This is 40 minutes, 3 times per week, at a challenging but sustainable intensity. It is what EXERT used in people who already had mild cognitive impairment. It is what Erickson used to grow hippocampal volume in a year. It is what the research most consistently identifies as the threshold below which the neuroprotective effects begin to attenuate. Adding high-intensity interval training, 2 sessions per week of 4 to 8 minutes at 90% of maximum heart rate, produces larger VO2 max gains on top of the moderate intensity base and amplifies the BDNF elevation that drives the most potent neuroplastic responses. The combination of moderate intensity aerobic base and high intensity intervals represents the training structure with the strongest evidence for both cardiorespiratory fitness gains and brain health protection across all ages. Resistance training adds a dimension that the aerobic evidence alone does not capture. The myokine research, particularly the data on irisin and BDNF secretion from contracting skeletal muscle, establishes that the brain health benefits of exercise are not exclusively cardiovascular. The muscle, as an endocrine organ, produces signaling molecules that cross the blood-brain barrier and directly support the hippocampal neuroprotective mechanisms that aerobic training drives centrally. The combined program, aerobic base plus intervals plus resistance training, activates the full range of exercise-induced neuroprotective pathways and represents the most comprehensive fitness investment for long-term cognitive protection. I want to spend time on the concept of cognitive reserve, because it is the framework that makes the urgency of the midlife fitness investment most clear and most intellectually honest. Cognitive reserve refers to the brain's capacity to tolerate pathological damage, amyloid plaques, tau tangles, vascular lesions, neuronal loss, before clinical symptoms appear. Two individuals can have comparable amounts of Alzheimer's pathology visible on PET scan or measurable in cerebrospinal fluid, and one will show clinical symptoms of dementia while the other will show none. The difference between them is their cognitive reserve, the structural and functional resources of the brain that allow it to compensate for pathological damage through the use of alternative neural networks, through more efficient processing of the same cognitive tasks, and through the sheer volume of neuronal connections that must be lost before functional thresholds are crossed. Cognitive reserve is built across a lifetime. Education, occupational complexity, social engagement, bilingualism, and mental challenge all contribute. And cardiorespiratory fitness is among the most potent contributors, operating through all four of the mechanisms I described: more hippocampal neurons through BDNF-mediated neurogenesis, more cerebral blood flow through vascular health, less neuroinflammation through anti-inflammatory adaptation, and the raw structural preservation of more brain tissue for pathological processes to erode before clinical symptoms emerge. The fitness investment in your 30s and 40s does not immunize you against Alzheimer's pathology. The plaques and tangles that define the disease are driven by genetic and environmental factors that fitness does not fully control. What fitness does is build the reserve, the structural brain capital, that allows a person to carry a greater burden of pathological damage before crossing the symptom threshold. The high-fit individual may develop Alzheimer's pathology at the same rate as the low-fit individual, but they cross the clinical symptom threshold years later because they have more brain to lose before crossing it. The 5 to 9 year delay in dementia onset that the fitness research documents is, in this framework, the practical expression of built cognitive reserve. The fitter brain has more of everything that Alzheimer's pathology destroys: more hippocampal neurons, more cerebrovascular capacity, more synaptic density, more cortical thickness. The pathological process consumes the reserve more slowly relative to the volume available, and the clinical threshold is crossed later, 5 to 9.5 years later. In a disease whose trajectory after clinical diagnosis averages 8 to 12 years, and whose years of disability and dependency fall heavily at the end, a 5 to 9 year delay in onset means years of functional independence, cognitive engagement, and quality of life that the low-fit trajectory does not provide. The age at which this reserve is most efficiently built matters for the practical decisions you make today. Hippocampal neurogenesis, the BDNF-driven creation of new dentate gyrus neurons that aerobic exercise stimulates, is more robust in younger brains than older ones. The vascular adaptations to aerobic training, arterial elasticity, endothelial function, capillary density, develop more readily and more completely in cardiovascular systems that have not yet undergone significant age-related compromise. The anti-inflammatory adaptations of regular exercise are easier to establish as a baseline before the pro-inflammatory drift of aging becomes entrenched. None of this means that starting in the 60s or 70s is without value. The Generation 100 study and the EXERT trial demonstrate clearly that exercise produces meaningful brain health benefits at any age. But the compound interest argument applies. The person who has maintained fitness from 30 through 70 has 40 years of accumulated neuroprotective adaptation working in their favor at the starting line, the Generation 100 study measured. The person who begins a serious fitness program at 65 has 5 years of such accumulation. Both have done better than the sedentary alternative. The investment made earlier produces a larger reserve for longer. The decisions you make about your training in the next 12 months are not only about your body composition, your metabolic health, or your cardiovascular risk factors. They are decisions about the brain you will bring to your 60s, 70s, and beyond. Every interval produces the BDNF elevation that maintains hippocampal neuroplasticity. Every hour of sustained aerobic effort maintains the cerebrovascular health that keeps the brain's oxygen supply adequate for the cognitive demands of the decades ahead. The cognitive trajectory of the second half of your life is not fixed. It is not genetically predetermined beyond your influence. The research says clearly that it is meaningfully determined by the fitness decisions being made right now, in the years when the compound interest on the investment is longest to run. The practical reality is this: you cannot undo the training years already missed. You cannot return to 25 and start the 4-decade compound interest cycle from the optimal starting point. What you can do is start the investment from where you are right now, letting it run as long as it can, understanding that every year of fitness maintenance from this point forward is a year of neuroprotective adaptation compounding in the brain you will eventually need most. If you are already training, if you have an established aerobic base and a reasonably maintained VO2 max for your age, the priority is protecting or adding the high-intensity work that produces the largest acute BDNF elevations and the fastest VO2 max gains. 2 sessions per week of genuine high-intensity interval training, in addition to your moderate aerobic base, is the most evidence-supported incremental brain health investment available to someone already physically active. The Norwegian 4x4 protocol, 4 minutes at 90 to 95% of maximum heart rate, 3 minutes recovery, 4 rounds, has been validated in multiple aging populations and consistently produces VO2 max improvements of 7 to 15% over 8 to 12 weeks. That improvement translates directly to the fitness metric the Generation 100 study found, still predicting brain structure 9 years later. If you are sedentary, if the fitness investment has been deferred to a future version of yourself who will have more time and a cleaner starting point, the biology is still available to you. The hippocampus is still capable of growing new neurons in response to the BDNF signal that aerobic exercise generates. The cerebrovascular system is still capable of meaningful adaptation. The anti-inflammatory response to regular exercise is still accessible. The window is open. It does not stay open indefinitely, and earlier is always better, but it has not closed. 120 minutes per week. 3 sessions at moderate to vigorous intensity. That is the minimum effective dose the research consistently identifies as the threshold below which neuroprotective effects begin to attenuate. Begin there. Build from there. Add the intervals when the base is established. Add resistance training for the myokine-mediated pathways that aerobic training alone does not fully activate. The neuroprotection literature has a problem with communication. The findings are published in Sports Medicine and Alzheimer's and Dementia and The Lancet. The researchers who produce them understand the magnitude of what they are showing. But the gap between what exists in the peer-reviewed literature and what reaches the people whose decisions the literature is most directly relevant to is enormous. The fitness decisions that most powerfully shape the cognitive trajectory of the second half of life are being made every week by people in their 30s and 40s who receive their health information from systems that have not absorbed the evidence and are not communicating it. The evidence says that the fitness investment made between 30 and 60 is the single most impactful preventive intervention available for the most feared age-related disease in the modern world. Not the most impactful pharmaceutical intervention. The most impactful intervention of any category in the research. More powerful than anything available at a pharmacy or a longevity clinic. Available for free. Improvable at any age. With a dose-response relationship that has no ceiling. Every session builds the VO2 max that the Generation 100 study found still predicting brain structure 9 years later. Every interval produces the BDNF elevation that maintains hippocampal neuroplasticity. Every hour of sustained aerobic effort maintains the cerebrovascular health that keeps the brain's oxygen supply adequate for the cognitive demands of the decades ahead. The brain at 70 is being built today.